Hey, welcome back. And this is called can place flowers. And so here you're given a array of just binary numbers, so just 1 and 0. And then you're also given a number n. And so what we want to do here is we're looking in this array and we want to see where can we place a number 1 wherever there's a 0. So you could place a 1 here, here, or here, but you can't place a 1 where there is a 1. And that's called placing a flower. And you can only place flowers where it's either on an edge here or the numbers around it are 1. And so in this case, you can only place a flower in this middle location, because if you put one here, there's a 1 already on the left of it, or if you put it here, there's already 1 on the right of it, and so you can only place it here. And this n is simply a check to see, can you place 1 flower? Yes, you can right there. Can you place 2 flowers here? No, you can't. You can only place 1. And so it's just the, can you place at least this many? Okay, so let's go ahead and implement this. So what we're going to use is kind of multiple pointers when we're looking at this. So you can imagine that we have a for loop and we want to check, and say if we're looking at this value here, we want to check after it and we want to check before it. But the problem with this, when you're dealing with multiple pointers like that, is you don't want to index outside of your array. And so you get edge cases here like, okay, start at index 1. You can't really look after it because that's an index out of bounds error. And if you check here, well, you're looking too far ahead, and that would be an index out of bounds error. So you have to deal with those edge cases. And so the first edge case that we're going to deal with is, what if we're past a flower bit of size 1? So it's either 0 here where there is no flower, or there is a flower here, and so it's 1. So to do that, what we'll do is we'll have an if statement, and so we're checking the length of the flower bed, and if it's equal to 1. So then, if so, if the flower bed in that index location is equal to 0, then we'll return if 1 is greater than or equal to the number that we're passed. Okay, so this is looking at the flower bed, and if there's no flower if there's no flower there, then we can place we can place 1 flower in that one spot. So if the array is 0, then that means there's no flower, so we can place just 1 there. And so in that case, if it's greater than or equal to n, so that we want to do greater than or equal to and not just equal to n, because we want to count for the case where n is equal to 0. So else we just return 0 is greater than or equal to n. So just to make this smaller, we'll just do return here, and I forget what this is called, but like the short form of an if-else statement. All right, and then next we're going to actually do our for loop. And so we're just checking, and at the end we're going to do return count is equal to n. And so we're going to iterate through our array, and whenever we find a spot where we can place a flower, we're going to increment our count. So we'll set that outside here. We'll just instantiate it to 0. All right, and so the first thing that we're going to do is check for the edge cases. So if we're in index 0, then we don't want to check behind it because that will be a null pointer. or an index out of bounds, and then we want to check for this edge case where if we're at the end, we don't want to check the one behind it. We only want to check the one before it. So if I is equal to 0 and the flower bed at 0 is equal to 0 and the one behind it is equal to 0. Or, yeah, the one after it is equal to 0. Then we increment our count. So count plus plus. And then also we want to set that actual flower because we want to, if we don't even set that actual flower, when we go to the next case, we won't realize that we already planted a flower just behind it. So flower bed at I will be equal to 1. And so next we want to handle the following case where it's kind of that edge case at the very end. So if I is equal to the flower bed's length minus 1. So we'll take that and set it here. And now instead of looking at like kind of I plus 1, we'll be looking at the I minus 1. And just for consistency, I'll just do I plus 1. And so that's looking at the flower bed behind it. So if we're here, we're only going to check the one behind it and not the one after it. So if that's all true, then we'll increment our count because we can place a flower there, and then we'll actually set it. And then so finally, we just want to set kind of our best case when we're kind of more in the middle, and you can check before it and after it. And so we're going to take all this, just make it quicker, and we're going to grab this. So if I doesn't equal 0, so if it's not the first flower area in our flower bed, or it's not our last, and we want to check if I, our current number, our current area is 0, the one after it is 0, or the one before it is 0, and the one after it is 0. And then one little quick thing we can actually do as well. Oh, and so this is wrong here. We want to check greater than or equal to n because, well, say if we can place 5, we want to still return true if we're past 2. Because this is just checking, can we plant at least 2 flowers? And so we can actually put a return statement here. So if the count is greater than or equal to n, we'll return here as well, just to finish earlier if possible. So we'll return true. Oh, and I actually didn't add our return here. So if this evaluates to true, they want to increment our count and set the flower bed at our current location to 1 once again. Okay, so let's try running this, see if there's any errors. No, let's try submitting it. Great, and success. So yeah, I think this question's, it's an easy question, but there's a lot of cases that you have to consider. And actually, I didn't fully understand the question the first time. That's why I kept erroring out. I didn't realize that you had to check the greater than or equal to case, but I think this is a great kind of 3-pointer question where you're looking at each, flower area at a time. You have to handle those index out of bounds errors, and then adding this little check before it all where you only have 1 flower plant. You don't actually have to check for when you only have a length of 2 because that's handled here. So we're checking those 2 edge cases. So it's handled there, but in this case, we really need to check it before we check this loop here. So yeah, I hope that helped, and good luck with the rest of your algorithms. Thank you.